Hello, good afternoon, uh, all of you. I am waiting the all student in this class to introduce about this course, MI 2036. The title of this course is about probability statistics and the random signal processes. The objective of this course is providing the basic knowledge of probability and random variables, one-dimensional and multi-dimensional, including probability distribution, characteristic of random variables, hypothesis testing, and estimations of random variables, and stochastic process and signal processes. So you see that's only short time about the 16 weeks. We have the syllabus to of this course provides you the basic knowledge. Related probability, random variable, hypothesis testing, estimation, random variables, stochastic signal, and stochastic processes and random signal processing. Okay. The contents of this course about the basic concept. Okay, basic concept of experiments, model, probability, random variables, one-dimensional as well multi-dimensional, probability distribution, okay, characteristic of random variable, random vector, hypothesis testing, estimation, random variable, okay, stochastics, processes, and random signal processing. Here the objective. About the general information, this course, the name is a probability statistic random signal. Sorry, MI 2013. Let I check it again. Maybe I'm wrong. Okay. It's my wrong. This is here. The lecture is 43. The course units here is 3. We have 3 hours for theory, 1 hour for practice, and 6 hours you have to study by yourself a week. We have about 10 hours per week for this course. It means that the lecture is 48 and the tutor is 16 hours. The required site is no, and required site core required site is calculus 1, calculus 2, or algebra. Parallel is no. So course description. This course covers follow area probability, statistics, and random signal processes. In many other universities, people often provide you only probability and statistics. The random signal processes is another course. However, in this course, we combine two courses, probability statistics and random signal processes. So your course is more heavier and and require you the deeply learning in stochastic, in the random event. To have this knowledge, we have to understand the experiment outcome, sample space, event, axiomatic foundation, probability formula, random variables, distribution and density, transformation and expectation, introduce both discrete and continuous familiar distribution, random vector, joy and marginal distribution, random vectors, hypothesis testing, estimation, random variable, stochastic process, and random signal processing. Here's a description of this course. The goal to outcome we have about the M1 is the goal. Understand able to do probability statistic and random signal processes. Here is the output level, is the introduction, T is the teach, and U is the understand. This goal, we have the level is the introduce and teach. M1.2 is understand problem involving one-dimensional is the introduce and teach. Here. And M13 is understand concept of vector, probability distribution, characteristic of random vector, and common distribution limit theorem about the IT. M1.4 is the practice application of theory, develop probability theory, and hypothesis testing. Things the foundation of many signal detection techniques. The level is IT. M15 is understand the basic concept of stochastic processing. You know that our course is about the signal random signal processing. However, it only the level I. I is mean introduce, okay, not teaching. So you have to read by yourself. The knowledge you get is dependent on you read what you read, and you have to learn by yourself. M1.5, you see that related the random signal process is the UI, level I, introduce. M2 is the applied probability statistic and random signal process knowledge to modeling and analyzing. It includes two small subgoals. It's the M21, is the understanding and apply probability statistics and random processes to analysis and create some model in real problem. It's the ITU. And M22 is the understand and apply three specialized materials. It's the I, introduce. Okay, here's the goal of this course. And course material textbook, we have this book, Probability and Stochastic Process, a friendly introduction for electrical and computer engineers. So you are electrical and automatical, so automate system. So you will use this textbook, okay? The name of the author is Roy Yates and David J. Goodman. The name of this book is The Probability and Stochastic Processes. Another reference, we can find the course of probability and statistics of author Tống Đình Quỳ, Bách Khoa publication. It's written in Vietnamese, so easy for you. The second is William Feller. Here is deeply theory about the probability theory, an introduction to probability theory and its applications. The publisher is John Wiley and Sons. It was published in the 1971. 5. About grading. Grading components divided in two parts. A1 is the process score, and the second is the final exam score. About the process score divided two parts. The first is discussion on class hour. You present your exercise, present your idea on the comment box. The outcome is the M11, M12, M13, 21, and 22. M11, 2 here, 21, 22, and M1 is here, related the goal, outcome of this course. And it have 30%. Addition, we have add with attitude grade. Attitude here is the process score will be adjusted by adding attitude point. Attitude points are words from -2 to +2 according to higher education regular of Hanoi University of Science and Technology. Because online, our School of Applied Informatics and Statistics will give different adjust score is a -2 to +3. Why +3, not +2? For you a chance. If you have only 7 in the test, midterm test, add with the grade, add with the attitude grade, you have the process score. If you have 7, but you have a good attitude, you still have a 10 score. If you have a good score, however, the attitude is not good, maybe you haven't enough score to do the final test. Okay, about the final exam score, it takes about 70%. The final test will writing or multi-choice in the case online. Okay, do you have any question for this?
Excuse me, can you teach bilingual, because it's my class, the most students have not finished English lesson. Có thể xong luôn, tại vì lớp mình nhiều bạn.
Some students have not English certificate or lesson. However, this course must be taught in English. If you don't have enough knowledge in about language, you can hold and you can subscribe in the next semester. This semester, this course must be teach in English only. Okay.
Yeah, right.
You have to understand. Here is the ruler of our university. I only teach in English. Vietnamese is not possible for this course. If you want to study this course in Vietnamese, I have several course replacement. However, because your program is an advanced program, So every course have to study English, and with my my role is lecture, I have to deliver this lecture in English. Okay. Do you have any question for this? This course is teach in afternoon, quite sleepy. And this course is difficult too, so I hope that it's not too sleepy for this course. Can you write down in the chat box how many percent for final test? How many percent the final exam score take? Can you write down on the chatting box? How many percent final exam score take of this course? Okay, very good. You understand. How many score? How many score you get with good attitude? How many score? How maximum? What is the maximum? What is the maximum score you get by adding attitude points? 3. Okay. Remember, it's different with this syllabus. It's plus 3. 2. Because we study the online, we can add 3. The detail here, the detail of plus 3 related this. We have 42 students in our class, and we have 15 weeks for check the absence or attendance. Okay, when I check the attendance in the class, if you don't have any week absent, you will plus 1. You will plus 1. If you have 1 absent, you plus 0.25. If you have a two week absent, you don't have at any point. If you have a 3 week absent, you will minus 0.5. If more than four times or 4 week absent, you will be minus 1 point. So please write down on the comment box, greater than 2 absent will be minus attitude point. Okay, write down on the comment box minus point. If absent more than 2 times, please. Could you write down on the comment box? My idea is that If you absent 2 times, more than 2 times, your addition point is minus. I see that Nguyễn Anh Minh write down 0.5 or minus 2 minus 1 is no, it's not right. If you absent more than 2 times, your addition is minus point. Okay. I would write down clearly to you. About the check episode. My computer is too low. Can you see? Terrible, too slow. I can add anything. Because the online is take all the load of internet. Okay, check episode. If you zero time, you will plus 1. If you one time, it's plus 0.5. 0 times, sorry, 2 times is plus 0. 3 times is a minus 0.5. It's more than 3. It will be minus 1 point. Okay, minus 1. And you see that I have set u is a minus 2 and plus 2. If absent attitude only this, it have only plus 1 and minus 2. Where is plus 2 and minus 1 more? It related about the assignment. Where is the assignment? Here's the assignment. Each week you have an assignment. I can show you several courses I did in the past. Three MI here, right? MI 2036. This card is the same. And you see here's the grade. Sorry, my computer is too slow today. It's too slow. I don't understand why internet has problem. I can illustrate that each week we have an assignment and you have to turn in time. And if you do all the assignment each week, you can plus 2 points. I will grade this and show you later because the internet it don't show to us here. Too low because this class about 100 students, so the data is low, is very low. Each week you see that we have a exercise. Follow each chapter. It's too low, too low. Not fast at all. I can illustrate each week we have an assignment. The exercise here I show you in the title of assignment, and the exercise will have in the textbook. And you do all the exercise in the textbook and you turn in time. If you do all of this assignment, you for 15 weeks, you will plus 2 points. Remember assignments. Not turning 0 times plus 2 points. If one time, if your status not turning one time, so you will plus 1 point. You see that all the week you turn in, you plus 2. But if you miss 1 week, you plus only 1. 2 times. You not turn in 2 times, you plus 0. If you 3 times, you minus 0.5. Okay, and more than 3 times, you minus 2. Minus 1. So you see that the check absent and assignment. You have plus 1, plus 2 is 3. And minus here is minus 1. Okay. Here you see that's the many. Here's the 100 students last year. This student is minus 1, and here is turning all the week is plus 2 points. And January. So the team is too slow. I haven't shown you. Let's show you the score. Where's the score? Where is score? I haven't seen the midterm score. Midterm score. This will be delete. It's a delete. I can see it. Okay. I couldn't show you. in the real +1 and +2 and -1 and -1 here. However, here is a ruler of plus or minus point about the wood manner student institution. Do you have any question about this issue? If not, if you don't have any question, I can continue about the course topic and schedule. The first chapter 1, we study about the experiments, models, and probability states. The goal is a related examination. A11, A1, A11, A12 is here, right? And A2 about the A21. Everywhere you see A1, 11, 12, and 13 is related about midterm test. About final term test is the A2, A21. Here, related midterm, here is the final test, midterm final test. However, about the week 10, A11, A12, A21. You can't see that A13, right? You'll never see anything from the 10 is the A13 because the A13 is related the midterm test. A11 is a homework and A12 is what it is? A11. Okay. A11 is discussed on the class and A12 is a homework. We have to do all the course barriers. Okay. Finish chapter 1. Finish the week 1. We moved on to week 2 about the conditional probability independence, sequence experiment, and tree diagrams. About the week 3 is the counting methods, independent trial. Week 4 we study about chapter 2, discrete random variable, about the definition, probability mass function, family of discrete random variable, cumulative distribution function, and average. Lesson 5 about the function random variable, expect value of derived random variable, variance and standard deviation, conditional probability mass function. Week 6, continuous random variable, chapter 3, cumulative distribution function, probability density function, expected value families of continuous random variables. Week 7, about the Gaussian random variables, delta function, and mixed random variables. 8, about the probability model of derived random variables, and conditioning a continuous random variable. Week 9, when we finish week 9, we have the midterm test. And midterm test, when we in the week 10, okay? Please write down on the comment box the midterm test. Midterm test in week 10. Please write down on the comment box. Midterm test in week 10. Can you hear me? Write down on the comment box. Midterm test in week 10. Okay. When we begin in the week 1, we have to understand that in week 10, maybe you don't want to do tests, you are sick, you have a problem with your health, with your family, and everything, and we have many reasons. However, our class still have the mid-term test in the week 10. Okay. And when we finish 16 weeks, we have the final test. Follow our university schedule. Continue when chapter 9 finishes. We have 10, 11, 12, 13, 34, 14, 15. At that time, you see that many new knowledge you get in the 16 week. This year quite different. We have the 16th week. You know that each hour we study 45 minutes, but in the international, each lecture have a 55 minutes. So they last only 15 weeks. But our university this year, it lasts 16 weeks. Why? Because each hour only lasts 45 minutes. So we need 16 weeks for enough the hour of this course. Okay. So the last week is a review, prepare for the final test, and the goal is the same. Okay. I will send you this. Okay, here is the Ruben by Summit. Give to each student, not only me, everyone. This course must be follow this syllabus. Okay. Now we have a 10-minute break. Before we have a 10-minute break, do you have any question to me? Do you have any question to me? Okay, 10-minute break. 10-minute break, please. I will come back. We will come back about in 10 minutes. Hello, can we continue?
Yes.
Okay, the second hour, we begin with the knowledge of probability and statistic and stochastic process. You follow the advanced program, so you use another syllabus with regular student. The knowledge you not focus on statistics, you focus on stochastic processes. So the way you work each week of this course different with the regular program. You have to remember this. You follow the international course. This international course by many lecturers of America. Okay. This textbook is for engineering, okay, for electrical and computer engineering. It's suitable with you, okay? You will see that if you understand the stochastic and stochastic process and signal processes, you have many decision choice. You can run from 1, 2, 3, 4, 5 here. It's each line here, each sentence here, chapter. One chapter, chapter 1, chapter 2, chapter 3, and chapter 4, and chapter 5. And if you want to understand the signal random process, you must follow this line. Here's the map, help you to guide you to study. You must be follow the chapter from 1 to 5 and 8 to 9. You can eliminate chapter 6, chapter 7, chapter 10, and chapter 12. However, if you want to study two random signal processes, you must study 1, 2, 3, 4, 5, 8, 9, 10, and 11. You remember we have only 16 weeks. Each line here is one chapter, have too many knowledge. In regular, people often study 1, 2, 3, 8, and 9. However, you are advanced program. You have to study 4, 5, 8, 9, 10, 11. So, of course, we don't have enough time. Requirement for students to understand this course, you have to study by yourself. Okay? So, we don't study chapter 5. We will study clearly 1, 2, 3, 5. Some small part in chapter 6. Chapter 6. Small part in chapter 6. 8, 9, and two chapters. Important. However, we don't have enough time. So it's only introduction. In the level introduce that I told you in the syllabus. Syllabus tell us first about the random signal process. Have introduced level. Okay. Here, chapter 1. Experiments, models, and probabilities. Let's start with probability. We see that in our life, some friend is good, some friend is bad. You don't like that friend. We only want to study good friend. If you color for the friend like that, oh, the good friend is white color, and bad friend with me is the black color. And what is gray? Gray is a color between 0 and 1. It means between good and bad, between the good friend and bad friend. And we see that in our life have many event color gray like that, right? You have only close friend with some people, and you think that the other is not good. However, large your friends are gray if you color for them. Okay, so probability is the way to measure who is good, who is bad, who is gray, who is between good and bad. So we will, to illustrate for that, we will study set theory that we study in the calculus and algebra. In the high school, you have studied several times. When you study in 6th grade and in the 10th grade, you have studied set theory. Now, this course, we have 1 hour to review one more time set theory. Okay? The term here is a set. An element. Union. Here's the operator. Operations of set theory have the union, intersection, complement. Okay? Now, the concept of set is a collection of things. A set is a collection of things. And things that together make the thing. The things that together make up the set are elements. The things that together make up the set are elements. Now, we have a set A. Element X and Y. And we have the symbol belong. This symbol denotes for inclusion or belong. Inclusion. And we said that X is an element of set A and denoted by X include A or X belong A. Okay. Opposite of belong, we have the not belong. Okay. So if we denote C doesn't belong A, means that C is not an element of set A. Okay. We can take a simple name of some university. A is a set. Include Rutgers University, Polytechnic University, the plant Mercury. Oh, here is different, not university, the plant Mercury. Now, we see that the set is denoted equal and between curly brackets. curly brackets. Okay. Now we have the question: sun include in A or doesn't include in A? Is the sun an element of A or not element of A? If you agree that sun is element of A, please say yes on the comment box. If you don't agree with my my statement, sun is an element of A. Yes or no? Write down on the comment box, please. The sun is an element of set A. Yes or no? I received only 5 students answer to me. The other, our class have 42 students. You know that the attitude belongs your answer in the chat box. You know that the development of technology, people will know who is the top interactive with the lecturer. Sun doesn't belong to A, the set A, okay? Good. It's still very easy, right? Bill Clinton doesn't include in set A, or in Bill Clinton is not an element of set A, okay? Now B. Also, Rutger Jr., who weighed more than 170 pounds. And here include all the junior of Rutger University who have weighed more than 170 pounds. Here's here is a set. If we can describe by mathematical ruler. Here's a C. C is the set of the element x squared that is equal 1, 2, 3, 4, 5. So when we present clearly the set C here is a 1. If x equal 2 is a 4, 9, 16, and 25. And another set is D. D is not a finite set. It's the infinite number. It's the x squared that is equal 1, 2, 3, and vice versa. You see that? A here's the finite element, and C is the finite element, and B finite element too. However, D is the infinite number of elements. Okay, D is the infinite number of elements. Now with definition, A we have the concept is a subset. Subsets describe a relationship between two sets. Definition: A is a subset of B if every element of A is also the member of B. A is a subset of B if every member of A is also a member of B. And the symbol here denote for subset. Symbol here is a denote for subset. Thus, A is a subset of B. It states that the set A is a subset of the set B. A is the set A is a subset of B. If we form simple, A belong to B, right? Or A is a subset of B, not the set. A is a subset of B. Now we have another relationship of two sets. It's A equal B. A equal B if and only if B is subset of A and B is subset of B. Okay, so we have the A equal B. We have the concept universal set. Universal set. What is universal set? Universal set is the set of all the things that we could possibly consider in a given context. If we consider what is the universal set of students in Hanoi University of Science and Technology, so we consider all the students who have the cast who enters our university. So it's considered the set of all the people who is the Hanoi University student. Okay, have to given context. Here is student who entrance our university. Okay. Now we have the concept universal set, and we often denote it as S. S is a sample. Sample is a set, universal set. And we have a new concept, is the known set. Known set is very, very important. It don't have any element. It is not a set at all. It is not a set at all. And definition, it have no element. The set have no elements. We call it is a null set. And we denote by the empty set here. An empty set is a subset of every set. Empty set or null set is the subset of every set. And for any A, so we can denote the null set is the subset of A. By a Venn diagram, A is a square here, is a rectangle here, is a subset of B. B is represented by the oval. And this rectangle, here's a universal set. So we can denote by A is a subset of B, and B is a subset of universal. Okay? Do you understand? If you understand this concept, the universal set, null set, belong, or subset, equal, please write down U. U is mean understand. If you don't understand, please write down U is understand, is N, not understand, N. I received 2 messages from you. For student, the other N or U. N is mean that not understand, and U is mean that understand. You when you reverse upside down, you see that is N, not understand. Okay, now I see that some students give to me the answer is understand. Now we continue studying about the operations of set. When we finish the operation, we have 10-minute break. Okay. We have 3 operations. First is union. The second is intersections, and 3 is complementars. The union intersection combine 2 existing sets to produce the third set. The complement operation forms new set from one existing set. The notion and definition are the union of set A and B creates the third set is A and B. A and B. A union B is union of set A and B denoted by A. Here's a cup, like cup, called union B. Is the set of all elements that are either in A or in B, or in both. Okay, either in A or in B or in both. So A union B is the third set that contains all elements in A or in B. If you see in the Venn diagram, so the gray color here is A union B. The element in A or element in B or both in A and B. So here is the set of A union B. Formula, we definition state X in A union B if and only if X in A or X in B. Okay, so the logical here is or. Now we move on the next operation is the intersection of 2 sets A and B. We denote is the A intersection B is the set of all elements which are contained both in A and B. So very important here is all the elements must be in A and in B. So here is when we see in the Venn diagram, here's the all element in A and all element in B, and the dark gray here is the A intersection B. Okay. Formally, the definition X in A intersection B if and only if X in A and X in B. Okay. The last is the complement of A. We denote by AC. See here's the first character of complement. Okay, is the set of all elements in A that not in S. All elements in S, sample space or universal set, but not in A. Formally, X in A C. If and only if X not in A. Okay, we have the difference operation. A difference between A and B. We denote A minus B. Contain element in A or element of A that not in B. Or formally X in A minus B if and only if X in A and X not in B. Or we can write down by another denotation. A minus B equal A intersection BC. Or AC we can write down is as different A. Okay, so to the minus written by intersection and complement. So the minus derived from intersection and complement. So people often use three basic operations. It's the union, intersection, and complement. If you understand, please say down, write down on the comment box you. And if you don't understand, please write down on the comment box is N. For the three operations of the set theory. Do you understand? Okay, 10-minute break, please. We will turn back at the 3:46. Break 10 minutes. Come back. Our lesson, please. We have a 10-minute break. I hope that you can wake up. We have just reminded about the theory set. Now we have the new concept, mutually exclusive. Mutually exclusive. What is mutually exclusive? Do you know before? A collection of set A1, 3 dots, AN, AI intersection AJ equal null set for I different J. Or we can say that the AI and AJ equal null set is disjoint. Okay, disjoint is the A and B are disjoint if and only if A intersection B equal null set. And mutually exclusive is mean all I different J, AI disjoint with AJ. Okay. The next concept is the collective adjective. What is the collective adjective? If we consider the collection of sets A1, 3.AN is collective adjective if and only if A1 union AN union 3 dot union AN equal universal set. Here, A and B disjoint. So the intersection of A and B equal null set. And A1, A2, A3. When you union here, it equal universal set. So we have two concepts, mutually exclusive and collective adjective. Can you tell me? If we have three, okay, I don't ask you more. I will remind in the future. We can denote by shorthand. Union of AI is a UI from 1 to N to show the union of N set. And intersection of N set is the intersection I from 1 to N AI is denoted for A1, intersection A2, intersection etc. intersection AN. Okay. Now we have the theorem. Theorem is a statement that we have to prove. The De Morgan law, if A union C B complement or A union BC equal AC intersection BC. Here's the proof. There are two parts of the proof to show that A union BC is a subset of AC intersection BC. Suppose X belongs to A union BC, imply that X is not in A union B. Hence, X not in A and X not in B. It means that X implies AC and X implies BC. So X implies AC intersection BC. About the reverse direction, AC intersection BC is subset of A union BC. You can prove similarly. Okay. Now the question for you. We have the quiz 1.1. You Can you tell me what is R? If we given a pizza at Galender's, either regular L, and Tuscan is T. In addition, each line may have a mushroom is M, or onion is O. The pizza calendar has a regular Tuscan mushroom onion, as described by a Venn diagram at right here. Mushroom is a oval here, T is a square here, and O is a circle here. And for set specific below, set the corresponding region of the Venn diagram. Where's R? Where's R? Can you write down on the textbook or on the notebook and take a photo and upload on the chat box? Where's R? I called 6 students. 6 students of our class have to solve this problem. Phan Đăng Anh.
Có ạ.
Okay, please do the question 1. Okay, set the corresponding region of a Venn diagram to show R. Okay. Nguyễn Ngọc Châu.
Có.
You work with the question 2 and union O. Okay.
Yeah.
Nguyễn Hải Đăng.
Có.
Question 2 and union O. Phạm Trọng Đăng.
Có.
First R union M. By Nguyễn Tuấn Đạt.
Có.
Intersection M. The last question. Trần Tấn Dương.
Có.
Okay. The last question for you is a TC minus M. Draw in the notebook and take a picture, put on the comment box. Okay. The other student of our class, you can work all this quiz, please.
Cô em có hỏi chi mũ si là đối ạ?
TC is a complement. It equals universal set minus T. Rectangle here is a T, so the outside is a TC. Mm. A oh A union intersection O. Here's a red color set. It's good. Thank you. Next, vấn đạt. Five. R intersection M. Intersection M is not true. Why? Where's R? The pizza have two types, Tuscan and regular. So here is not R. Inside of Tuscan is not R. So sit here, you set here only M, not intersection with R. Please do it again. TC minus M. Oh, where here's a T, here's a M. TC here minus M. It means that it's in all the element in TC, but not in M. TC is here, but not in M.
Not in N.
Okay. TC is here, but not in M. Correct. Very good. Next. M union O. M here and O here. Very good. Okay. The other student? We have 6 questions. I received only 4 answers. 2 students, where's your solution? Okay, please send to the comment box later. We have just finished set theory. Now we continue, move on, applying set theory to probability. Maybe this week we always study 3 lessons. Lesson 1 is set theory, and lesson 2 is applying set theory to probability, and lesson 3 is the probability axiom. About the lesson 4, some consequence of axiom, I will teach you next week, because this week we have 1 hour to introduce our lesson. Okay, and I show you some ruler of our university with this course to you and to me. We still have 2 lessons. 1.2 is applying set theory to probability. Okay, applying set theory to probability. Now we have the concept. What is the experiment? What is experiment? What is the experiment? Experiment is a new concept of this course. An experiment consists of produce and observations. A experiment consists of produce, procedure, and observation. There is uncertain in what will be observed. The performance of experiment would be unnecessary. Some example of experiment. Flip a coin. Flip a coin have many procedures. To have a coin, who is a flip? And second, where you flip that coin? The coin we flip is fair or not fair. So you see that when you describe the procedures, we have a lot of steps. And now with observation. Observation is a result of flip a coin. There are two results. Head, when we observation head or tail facing up. If its head appear, we call the result is head. It reverse. If tails occur, we call that is a tail result. Okay, so an experiment consists of many steps, and we call a procedure. And then we observations the result of the procedure. Okay, so we have the concept outcomes. An outcome of an experiment is any possible observation that of that experiment. Outcome is any possible observation of that experiment. Okay, and we have the new concept here is a sample space. The sample space of an experiment is the finest grained, mutually exclusive, collective exhaustive set of all possible outcomes. Outcome is any possible observation. Outcome is any possible observation. And sample space is the finest grained, mutually exclusive, collective exhaustive of all possible outcomes. What is the finest grain? Finest is grain means all possible distinguished outcome. All possible is distinguished outcome are identified separately. And it's more that we can divide it or separate smaller. And then all the elements must be mutually exclusive or collective exhaustive. Okay. Now you can look one more time two concepts. First, outcome, and second, the sample space. with me for a moment, please. Advanced program. Okay. Please wait me for a moment. I hope that I can show you more clearly. I forget that I introduce myself as Nguyễn Thị Ngọc Anh. It's not dry. Okay. An experiment consists of procedure and observation. Example, an experiment consists of procedure, flip, coil, and observation is the head and tail place. Outcome of experiment is any possible observation that experiment. Sample space of an experiment is a finite square, mutually exclusive, collective exhaustive set of all possible outcomes and denote is S. Example, roll a six-sided dice and observe the number of dots on the side facing upward. Let's label outcome I, where I denotes for outcome that I denote appear. And you see that sample space equal 1, 2, and 6. We have many outcomes. It's even dot, so odd dots. All of them is outcome, right? It's outcome. Outcome is possible, any possible observation. However, because sample space only get the finite square, so even or odd dots is not the finite square. The finite square outcome is we can separate. Okay, so S is here. And how do you remember mutually exclusive? Mutually exclusive is mean that if it occur one, it will not occur six, or I or J. I and J intersection equal null set. And union of all the elements in this universal set is the mutually is collective exhaustive. Collective exhaustive is mean that union all the finite square now come here equal universal set. Universal set is the same called the sample space. But sample space satisfies three properties: finite square outcome, mutually exclusive, and collective exhaustive. Okay. And what is event? Event is a set of outcome of an experiment. It means that event is a subset, is any subset of the S of sample space. Event is any subset of sample space, or any subset of sample space is called event. Example A, row is even. Even here's a 2, 4, and 6. Here's a subset of S, so we call that A is even. Okay. Now we have 4 concepts: an experiment, outcome, sample space, and event. If you understand, please write down on the comment box. It's U. If you don't understand, please write down N. Do you understand? If you understand four concepts, an experiment, outcome, sample space, and event, please write down you on the comment box. If you don't understand, please say N. Okay, I continue. Example, the sample space of example 1.1 is mean that we flip a coin and H here denote for head, observer head, and tail T is the denote for outcome is the observer tail. And when we consider the exam 1.2, what is the exam 1.2 here? We flip a coin 3 times. Observe the sequence of head and tails. Flip a coin 3 times. So here's the first time, the second time, third time. And head is one possible outcome. Here's one outcome, one outcome here. And how many outcome of the sample space? Each time we have two possible results. So we do 3 times. So it's 2 times 2 times 2. So it equals 8. 1, 2, 3, 4, 5, 6, 7, and 8. Here is the 8 finest grain outcome. It satisfies intersection. Two outcome in the sample space is disjoint, or we call that 8 finest grain outcome here are mutually exclusive, and union all of them are collective exhaustive. Okay, now we consider the example 1.3. Flip a coin 3 times. Observe the number of heads. Observe the number of heads. Because 3 times, so it's 0 times head occur, or 1 time head occur, 2 and 3. So here's the example of sample space. Now we consider example 1.5. Manufacture an integrated circuit and test it to determine whether it meets equality of X. The possible outcome are accept. We denote is A and reject is R. So the sample space is AR. It's quite similar with when we flip a coin. Now with the test of circuit, have 2 possible outcomes accepted, or rejected. Okay, accepted we denote is the outcome A, and rejected is the outcome R. And sample space now is A and R. And A and R is a finite square, disjoint, and collective adjective. Okay, so here's a 5 examples. Help us to understand 4 concepts. What is experiments? We see that we have to do many steps. That is procedure. Okay, schedule. And we observe the experiment. Is the accept or reject, tail or head, or the number of head depending on the question we solve. The context question. So illustrates the experiment, outcome, sample space, and event. An event here is any subset of sample space. An event is a set of outcome of an experiment, or it is subset of experiment. Now we consider the example 1.6. Suppose we roll 6 die, side die, and observe the number of dots on the side facing up. We can label the outcome I equal 1 to 6, where I denote for outcome that I dots appear on the up face. The sample space S equal 1 from 1 to 6. Each subset of S is an event. Each subset of S is an event. Here's the definition of event. Any subset of S is an event. Empty set is a null set, is an event. And the sample space is an event. And any subset of S is an event. Event E1, row 4 or higher. So it's a subset of S. Include 4, 5, 6 elements. And event E2 is a row, is even, is true for 6. Here's a subset of sample space, so it is an event. And E3 is a row, is square or of an integer. Square here is 1 and 4. So we have many types of events. Okay. Or you can read by yourself example 1.7. I consider example 1.8 because it related many exercises of this chapter. A short circuit tester has a red line to indicate that there is a short circuit, and a green line indicates that there is no short circuit. We call it electrical engineering and automatic engineering. So you have know what is a short circuit test. Okay. Consider an experiment consists of a sequence of 3 tests. Each test, the observation is the color of the line that is on at the end of a test. An outcome of the experiment is a sequence of red and green lights. We can denote each outcome by 3-letter words such as RJR, red, green, red. The outcome that the first and third lines were red, but the second line was green. We denote the event that green iron was red or green by green. Rn and Gn is the event, thus the red at the time n, and Jn is the green at the time test n. So R2 is mean that here either includes all of the elements that the red at the second time test. Okay. We can also denote the outcome of intersection Ri and Ji. For example, the event R1, G2, R3 is a set containing single outcome. Red is the first time, the second time is green, and the third time is red. Is here. So from this, we can define many events. Okay, event space. Now we have the fourth concept, event space. When we finish event space concept, we break 10 minutes. What is the event space? We have just studied the sample space. Now we have to work together. What is the event space? An event space is a collective adjective and mutually exclusive set of events. The difference with sample space is the finite screen collective adjective mutually exclusive of outcomes, but here is the events. So the difference of sample space is the outcome. The members of sample space is outcomes as outcomes, but the event space, the members are events. The difference with outcome and events here. Now we look at the sample space. Sample space is A and AC. A is the state gray here, and AC. We call that A and AC are sample is event space because A and AC are mutually exclusive. Because A intersection AC equal null set, and AC union A equal sample space. Sample space. So A and AC is sample event space. Always look to these fingers. B1, B2, B3, and B4 is event space. Here, B includes for event here event space because they are mutually because both B is mutually exclusive and collective adjective. And C1, C2, C3, C4 is C1, C2, C3, and C4 is event space or not event space. Please write down on the comment box, please. C1, C2, C3, and C4, when you see in this Venn diagram, is C. 4C here, C1, C2, C3, C4 is event space. Yes or no? Write down on the comment box, please. Can you tell me? C1, C2, C3, C4 is an event space? Yes or no? Write down on the comment box. Yes, if they are event space. No, if C1, C2, C3 is not event space. Could you understand? Do you understand my question? In the Venn diagram, so in this finger, C1, C2, C3, C4 is the Is this collect of event here? Is the event space or not? Is not event space? If you think it's true, event space, please say yes. If you see that for event here is not event space, please write down no. One minute for you. I received only 5 students. No one answer me. Poor of me. The solution C1, C2, C3, and C4. The collect of 4 C1, C2, C3, and C4 is not event space. Why? Because union of it is not the sample space. It only this set. The outside we don't have enough for union all of them equal sample space. So C1 and C4 is not event space. Event space, an event space is a collective, exhaustive, mutually exclusive of events. It's like this: B1, B2, 4, or A or AC. Remember AC, A complement here. Union equal event space, a sample space, and A and AC is null set. And B1, B2, B4, 3, B4 is the event space. But C1, C2, C3, C4 is in event space. Okay, break 10 minutes, please, and then we continue studying. Break 10 minutes. Okay, we can come back. Can you come back to study again? The answer here is a C1, C2, C3, and C4. The collection of three events here is not sample event space. Okay. Event space. Event space is a collective, associative, mutually exclusive set events. A1, A2, AN are event space if and only if AI intersection AJ equal empty set for all I different J and I J equal 1 to N, and union N event here is a sample space. Example, roll a 6-side dice and observe the number of dots on the side facing up. The event A is roll is even 2, 4, 6, and the event B roll is odd 1, 3, 5. So A, B is the event space. Collect two events here. A, B is event space. If we consider event A1 is 1, 4, A2 is 2, 5, and A3 is 3, 6. You see that two event A1 and A2 equal disjoint. A1 and A3 is disjoint. A2 and A3 disjoint. And union A1, union AB, A2, union A3 equals sample space. So A1, A2, and A3 is event space. Now, do you understand event space? If you understand, please write down you on the comment box. If you don't understand, please say no. Okay, good. Now the quiz. So quiz, I will form 8 students to do this quiz. Monitor 3 consecutive phone calls going through the telephone switching office. Classify each one. Sorry, I am touching my face. Sorry, the sunshine in the afternoon. Monitor 3 consecutive phone calls going through a telephone switching office. Classify each one as a voice call. It's denoted by B if someone is speaking, or a data call is G. G is a data, right? And B is voice. If the call is carrying a modem for a fast signal, it's a voice. It's a voice call is B, and data call if a modem has fast signal. Your observation is a sequence 3 letters. Each letter is either V or D. We have only 2 types of call: is voice or data. Okay. For example, 2 voice calls followed by 1 data call corresponds to VVD. Write the elements of the following set. Now we have to find out the event based on the denote of B and D. Okay, Now I will call randomly. Lê Đức Hải. Lê Đức Hải. Absent?
I'm here.
Oh, sorry. Okay. Lê Đức Hải, A1. Please write down on the comment box. Lê Quốc Hưng.
I'm here.
T1. First call is a data call. Nguyễn Đức Huy.
I'm here.
A3. A2. Second call is voice call.
Yes.
Lê Chi Trung Kiên.
Yes.
Question 4. B2. Second call is the data call.
Okay.
Phạm Văn Kiên.
I'm here.
Phạm Văn Kiên.
I'm here.
Phạm Văn Kiên.
Yes, I'm here.
Okay, okay. 5. All call are the same.
Yes.
Okay. Phạm Chí Linh.
Yes, I'm here.
Okay, 6. B3. Voice and data alternative.
Yes.
Nguyễn Anh Minh.
Yes, I'm here.
Okay, 7. A4. One or more voice calls. The last one. Nguyễn Phú Nhật. Minh Nhật.
I'm here.
Okay, number 8. Before 2 or more data calls. Begin. Let's see the event for second call is a data call. The second call VDV, VDD, DDV, and DDD. As I see the 2 times 2 is 4 for finest outcome. Here is the finest grain outcome. So for the event 4, the second core is the data. Before is the 2 or more data core. 2 or more data core is the VDD. Okay. VDD, DVD, DDV, and DD. Right, correct. B3, voice and data alternate. Voice and data alternate. VDV, D alternate V and V alternate D here. DVD, correct. A3. A3 is the all core are the same. VVV, DTD, correct. B1, first call is data call. DVD, DD, A1, B1, B1, DDV, DDD. It's wrong. Why? It's not enough. You have a list only 3. You must list 4. DVV. You miss one. Finest outcome is DVV B1. Lê Đức Hải, you forget that the event have to describe by curly brackets that I show you in the previous lesson. Okay, write down like this. Not is like this. Okay. Continue A1. First score is voice call. First score is voice call. Okay, good. But must be use curly brackets. A2, where's A2? Second call is a voice call. Second call is voice call is wrong. Why? You miss one outcome. Where's one outcome? DVD, DVV, VVD. Where is the miss here? VVV. You miss one VVV. The second core is voice call. You miss. The we miss one. Finest outcome is VVV. Okay. The other B3, B4. Okay. I have just checked all the solution of the quiz 1.2. Now move on. We have just finished apply set theory to probability. Now the last knowledge of this hour is the probability axiom. Okay. Probability axioms. What is the axiom? Who can tell me? What is the axiom? I called 2 students. Nguyễn Bá Quảng.
Yeah.
Are you there?
I'm here.
What is axioms?
Axiom.
Yeah. The second one, Vũ Xuân Trường. Are you there? Vũ Xuân Trường. Sorry, Vũ Văn Trường.
Có.
Okay. Could you tell me what is the axiom?
Sorry, I don't know.
You have a Google in your hand. You can write down on the Google what is axiom. I think Wiki will tell you. Axiom you study in the calculus, in the algebra, in the high school. So here's the first time. Many times you know that the axiom of Euclid and Lobachevsky have a different axiom. They give to us the different theory about the geometry, right? So now is the axiom. I call Tạ Thanh Tùng. What is axioms? Thanh Tùng, are you there? Tạ Thanh Tùng. Tạ Thanh Tùng absent. Hoàng Đức Việt. Hoàng Đức Việt.
Có.
Okay. Can you tell me axioms?
Yeah.
What is axiom?
Axiom is I don't know.
Do you know axiom in Vietnamese? Đặng Thái Sơn. Đặng Thái Sơn. Are you there?
Yes, I am here.
Okay. Can you tell me what is axiom?
I
And
think
can you try?
I
Yeah,
think
okay.
is a statement that is taken to be true.
Okay. Can you translate the axiom in Vietnamese for your friend can understand?
Em nghĩ là axiom nó là một chân lý hoặc là một tiên đề. Nó là một nhận định mà coi là đúng.
Okay. Good. I have a call for student and some can tell to the other student of our class that axiom is statement that we accept is true, not proof. Okay. And now we have a definition, probability axiom. We have the sample space or universal set. There is the map 1-1 between theory set to the event. Universal set is an empty sample space. Event is a subset of sample space. So all the relationships belong or equal, and all the operations like union, intersection, and complement true for theory set, still true for the event. Okay. So the set of theory represent all the event or the outcomes and event of the experiment. The operation is the same with the set theory. Now we assign probability PA is probability of event A. Is the probability of event A. And in mathematical, we use this definition, axiom of probability, denoted by P embrace here, a blanket here, is a function that maps events in the sample space to the real numbers. P is the map of events and the real number. That satisfies three axioms. The statement true, accept true, not true. Any event A, we have a probability of A greater than 0. Axiom 2, the probability of sample space equal 1. We consider all the outcomes in the sample space and probability of sample space 1. And the test, we see that axiom 1 and axiom 2 observation is very easy to image and easy to accept. However, the difficult in ACM3. The history of this course, we know that Egypt evolution, many Egypt people very clever. They use mathematics in all of their life, and probability is used for measure the field. However, this definition derived in 1959. So this definition have the history is not enough 70 years. It created about 70 years ago only. Very short time comparing with the other mathematics theory. Okay, why? Because the ACM3 is difficult to understand. For any countable collective A1, A2, mutually exclusive event. What is a mutually exclusive event? Nguyễn Hoàng Sơn, can you tell me? A and B is mutually exclusive event. What does it mean?
Sorry, can you repeat the answer and the question?
What is a mutually exclusive event? A1 and A2 is called mutually exclusive events. What is the formula to show that A1 and A2 are mutually exclusive events? Sơn, do you know?
Sorry, I don't know. Sorry.
Who can tell me what is can you write down on the chatting box? What is a mutually exclusive event? A1, A2. No one answer to me? No one chatting box? Oh my God. Why? No one answer me. What is a mutually exclusive event? A1 and A2 mutually exclusive. It means A1 intersection A2 equal empty sets. Even Agapipura Tikira Mihari said to me, event we don't have any common event. No. Phương Nam says that biến cố độc lập is not right. It's not true. Independent and mutually exclusive is different concept. Mutually, I have said that is A1, A2, AN, vice versa here is AI intersection AJ equal null set for all I different J, right? So probability of infinite event but countable is A1 union, A2 union, vice versa, equal probability of each event. It equal probability of A1 plus probability of A2. You see that probability is the map. Probability is the map. Easy for you to emit. It's a map from the sample space to the real number set. Real number set. It's a map. Each event A in the sample space, we have the we have the number in the real number set, right? And because BA greater than 0, and all of the event is a subset of X, so begin is 1. Or we can say that B is a probability, is a map from the sample space to the interval 0 and 1. So it is a function, or it is a map. Satisfy three axioms. BA greater than 0, BS equal 1, and here, infinite countable collect event mutually exclusive. Probability of union equals sum of all the probability of each event. Okay, so the probability is a number between from 0 to 1. Statement 3 said that probability union of mutually exclusive event is the sum of individual probability. Axiom 3 said that union of mutually exclusive event is the sum of the individual probability. Because we accept not proof, so people use this definition to prove the other properties. The first theorem, theorem 1.3, for mutual exclusive event A1 and A2. A1 union A2 equal probability of A1 plus A2. No. This theorem we can't improve immediately. Now, could you prove probability of null set equals 0? If you want to prove the theorem 1.3, you have to prove probability of empty set is 0. It's the exercise in the end of this chapter, and I will give you the exercise for you to do at home. And there is the denote the level of exercise. Level of exercise here. We have the circle. Circle is mean easy, and easy. And now we have the symbol is the square. It mean moderate, and one diamond is difficult, and two diamond is the expert over is mean very difficult. And the test, midterm test and final test always in the level difficult and expert always. When you study, you practice the easy level, moderate level, difficult level, and expert always. However, in the midterm test, always in the level difficult and expert. Okay, you know that's our university. And 1.5 here. We use the axiom probability definition to prove that probability of empty set equals 0. Okay, from this we will prove the theorem 1.3. A and B are mutually exclusive and prove that probability of A union B equal probability of A plus probability of B. Okay. Where this? Yeah. A union 2, A1 union A2 equal probability of individual. To prove this theorem, we use axiom 3. This is not so in the simple proof of theorem 1.3 may also use axiom 2. No. If you are curious, it's a problem 1.4.8. Here's a problem that I have to show you 1.4.8. Please do it at home. The theorem 1.4. Here we have a not infinite event. We have a finite m event, countable and finite, so it is A1 to AN. And mutually exclusive is mean AI intersection AJ equal empty set for all the I different J. So we have a probability of BA union of M event equals sum of M individual probability. And the last theorem, so no, not last theorem. We have several theorems. So theorem 1.5, probability of event B. Event B have M outcomes. Finite gain outcome here, S1 to Sm. So probability of B, probability of event B equals sum of probability of Si. Because B prove that because B is a union of all the finite grained outcome, so it's the union of them. And because the finite grain, we know that all of them are mutually exclusive, or we can say that Si intersection Aj equal empty set for all the I different J. Follow the theorem 1.4, probability of B equals sum of probability of all of the individual from I1 to N. So we have the theorem 1.5. Okay. Comment on the notion. Probability blanket here indicate probability of event. The expression in the square brackets is an event. Square brackets. Probability square brackets. And with the contact one experiment, BA can be viewed as a function transform event A to the number between 0 and 1. BA is a map or a function from the event A to the number between from 0 and 1. Okay. Sometimes we use curly bracket Si only the element Si. So we can write probability of Si replace for probability square brackets, curly brackets Si here. And to reduce many operations, sometimes we use A union B by A, BA, comma B, or probability of AB. Okay, remember AB is mean that A intersection B. Okay, and the last And the last knowledge is equally likely outcomes. Equally likely outcome we study in the high school. The high school tells us that all the outcomes equally and likely, and the number of outcomes is finite. Finite. Okay. For an experiment, sample space S is at 1 to n, and here is a finite outcome. And each outcome Si is equally likely. So, probability of Si equal 1 over n. Now we prove it. We know that probability of S equal 1. Follow the axiom 1. Okay? And follow the theorem 1.5. Probability of S equals sum of probability individual. It means PS1 plus probability S2, etc. plus N. Because equally, all of them have the same value, so it's NP. Because PS equal 1, so P here is 1 over N. Okay, P 1 over N. Or PSI equal 1 over N for all the I from 1 to N. Okay, so do you understand? If you understand, please write down on the comment box you. If you don't understand, please say something different or write down N. It's no. Do you understand this theorem 1.6? Probability of Si equal 1 over N. If you understand, please write down U. If you don't understand, please write down N. I received 3 comments of many students here. We have only 10 minutes left. "37. We don't have a 5 student. I will check. Where's 5 student? Tạ Thanh Tùng, are you there? Tạ Thanh Tùng. Phan Sĩ Tú. Phan Sĩ Tú, are you there?
I'm here.
Okay. Nguyễn Lưu Anh Tài.
Dạ có.
Phạm Phương Nam. Phạm Phương
I'm
Nam.
here. I'm here.
Lại Đức Long.
I'm here. I'm here.
Trần Tấn Dương. Trần Tấn Dương.
Here.
Trần
I'm here.
Hoàng Hà. Ok, Trần Hoàng Hà.
Đây ạ, em có.
Lê Đức Hải.
Có.
Bùi Đức Hiếu. Bùi Đức Hiếu Epson. Bùi Tuấn Hoàng.
Có.
Lê Quốc Hưng.
I'm here.
Nguyễn Huy Hùng.
I'm here.
Nguyễn Đức Huy.
I'm here.
Nguyễn Văn Huy. Nguyễn Văn Huy.
Có.
Trần Quang Khải. Trần Quang Khải. Are you there? Absent. Lê Chí Trung Kiên.
Yes, I'm here.
Nguyễn Trung Kiên. Nguyễn Trung Kiên.
Yes, I'm here.
Phạm Văn Kiên.
I'm here.
Phạm Chí Linh.
Yes, I'm here.
Lại Đức Long.
I'm here.
Nguyễn Thành Long.
Yes, I'm here.
Thành Luân. Nguyễn Thành Luân. Luân absent. Cấn Xuân Minh.
I'm here.
Nguyễn Anh Minh.
I'm here.
Nguyễn Nhật Minh.
I'm here.
I still one student. I can't find. Phạm Phương Nam.
I'm here.
Nguyễn Minh Phú. Nguyễn Minh Phú.
Yes, I'm here.
Nguyễn Bá Quảng.
I'm here.
Nguyễn Minh Quang. Nguyễn Minh Quang. Nguyễn Minh Quang absent.
Cô ơi, bạn Quang thay ở trong chat ạ.
Oh, okay. So I find for student absent. You can check it. Now,
Cô trừ cho anh em cô ạ.
many students I call previous, so I remember. And here's Tạ Thanh Tùng absent, Nguyễn Thành Luân absent, Trần Quang Khải absent, and Buổi one student left, but tired write down on the comment box is okay, accepted. Now finish for this week. Please do the exercise from 1.1, 1.2, 1.3, and 1.3. Okay, is an assignment. Assignment is all the exercise. All the exercise from 1.1, 1.1, 1.2 here. 1.2.3, 1.2.4. I only consider 1.2. I write down is 1.2. Okay, 1.2 is mean from 1 to the end is 1.6, and 1.3. 1.3 is mean that all the exercise from 1.3.1 to 1.3.5. Okay, do you remember? Because the first week, so you see that your level is easy. No, I think that there is a 1.3 group. 1.3 group the theory. Here, it's a 1.4. Oh, why 1.4? Here. Can you do 1.4? Maybe I will look at 1.1, 1.2.3, and 1.4.7, and 1.4.8, 1.4.9 for you understand clearly about the axiom, probability axioms. Okay, finish for this week. Goodbye. See you next week.
Can you create assignments?
Challenge.
Can you create assignments?
Okay, okay, I understand. I will do it. Okay, goodbye.
Yeah, goodbye, teacher.
Goodbye, teacher.
Goodbye, teacher.